Hey Algebra 1, it has been a minute and I have been meaning to get this posted for you, so I'm glad at least I can do it now. Even if you feel like you've already worked through the work that went along with this particular lesson, do look at the whole lesson and try to make sure that everything kind of makes sense. All right, so we are in chapter 12. This is the last section of chapter 12, 12.9, and we're solving rational equations. So what is a rational equation? Well, let's discuss. Here we have written two separate rational expressions. We've been working with that for a while, but it becomes a rational equation if I can bring them together and maybe set it equal to something, or even set them equal to themselves. So a rational equation can look anything like this, or adding several rational expressions together to be equal, or subtracting whatever to be equal to something. But the key here is that when you have a rational equations, you've got rational expressions and an equal sign. Work problems are types of problems when you find out that some person can do a job in like 5 hours. So you might be talking about me. Dion takes 5 hours to rake leaves. And maybe my husband, Jason, takes 4 hours to rake leaves in that same space. How long will it take us working together? Well, not 9 hours, because that's insane, right? It shouldn't take us longer. Well, maybe it would because we'd be daydreaming. But it wouldn't take us longer if we're working together at the same rate that we would if we were working independently. So how much longer would it take? And so that's the type of problems that we're going to talk about when we discuss work problems. Let me get rid of that so we can get other things here. And then so the next one is rate problems. And rate problems can come in a couple forms where we're trying to figure out what is the miles per hour or some particular rate. Sometimes we will be using rate times time is equal to distance. So rate problems can include distance. It can include kind of changing things. So if I can think about miles per hour, or actually miles would be MI, or meters per second, translating those things from one set of units to another. So we have a couple of different types of problems we can look at in terms of rates. And finally, extraneous solutions. Sometimes this goes back up to problems like this. Sometimes we'll be solving one of these problems and then you might get in the denominator, like in this denominator, if this were a problem, we would see that x could not equal a plus or minus 5 because either of those values would make a denominator 0. But if after I started working on the problem, I got plus or minus 5, then I know that those are extraneous solutions and I got to get rid of them because they don't actually satisfy the equation. So that was a quick preview of what we're going to talk about. Let's get into the weeds. So here is our first rational equation, and you guys are actually already know how to solve these. We've done these earlier in the year where you do cross multiplication, so your instinct on that was right. So when we do that, we know that the product of the means is equal to the product of the extremes, which basically for us just means multiply it that ways, multiply it this ways. This only works when you have two ratios set equal to each other. If I added a little bit of 4 over x minus 7 or something over here to the problem, you can no longer cross multiply like that. So I just wanted to throw that out there. So once you got two ratios equal to each other, we are good to go. I'm going to multiply these guys together and we get this. And when I multiply these two together, we get that. And so now we have a problem that's really up our wheelhouse. We're comfortable with this. We distributive property through. We get 12x plus 24 is equal to 4x plus 20. And now we're going to choose one side for our variables and the other side for our constants. I haven't done this in a long time with you guys. All right, subtract, get rid of the x terms on this side. So I have all my x terms over here. So I end up with 8x plus 24. This constant needs to move to the other side. So I'm going to subtract 20 from both, 24, sorry about that, got kind of hype. I'm going to subtract 24 from both sides. I get that 8x is equal to, over here 20 minus 24 is going to be a negative 4, and therefore x is equal to negative 1/2. And so when I look at the problem, and you always have to do this, you need to look to see what would have made the denominator 0. And here I know that x cannot equal a negative 5, nor can x equal a negative 2. Since my answer is neither of those, we're good. We can plug it back in and check it. I'll save that for you guys to do. I'm going to go on to the next problem. Here, example 2, we're going to need to look for a least common denominator. And we've been doing that when we were joining terms together to add these rational expressions. So we're going to do the same thing, but this time we're going to do it across the board. So across the board, well, first, this is what I like to do. I like to really say, okay, well, let's get the common denominator. The common denominator will be a product of n and n minus 6, because then each of these denominators can be in there, if that makes sense. So my new denominator, let me write that down, is going to be n times n minus 6 for all three parts, right? And then so I have my minus sign here, my equal sign is still here, and n becomes like this. Now this fraction, or this rational expression, becomes n minus 2 at the top times n minus 6. So now these are equivalent fractions, because if I were to cancel that out, I'd have n minus 2 over n. But I want the common denominator, so I'm not canceling that out. And continuing on with that, this would be n times n minus 3, because if I cancel the n's out, I'd have my n minus 3 over n minus 6. And here I made a mistake, so I'm going to fix that. The only thing I need to add is n minus 6 to the numerator, because if I cancel that out, I have 1 over n. Woo! Now that we've got that together, let's talk about what the denominator cannot be. We know that n cannot be, given the denominator, n cannot be 0 and n cannot be 6. All right, so we can't have n equals 6 or 0. So I'm going to hold that off as I think about solving this problem. Now, the real thing is, you know that if I were adding fractions, like if I had like 1/5 plus 2/5, and I said, hey guys, what's this going to equal here if I have a 5 in the denominator? You'd be like, 3, lady, because you would tell me just to add the numerators. Because we know that once the denominators are all the same, it's really just the numerators that matter. And with that in mind, and with us already taking out the caveat of n cannot equal 0 and n cannot equal 6, we're going to go like this. Whoa, 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 whoa. I have no need for the denominator anymore, okay? So now this problem really just is about the numerator. So I'm going to rewrite this in a better way. So here I am just rewriting the numerator. And then what I'll do is solve this as if it were a problem that I've had, you know, in chapter 9 or something. I'm going to FOIL this out, n squared minus, so when I FOIL it out, I'm going to FOIL this out. I'm going to distribute this negative n through, getting rid of the parentheses, and I'm going to set all of that equal to n minus 6. And after doing that, I get my, oh no, better. I get my expression that I'm going to work on, n squared minus 8n plus 12n minus n squared plus 3n minus n minus 6. So now I'm going to simplify each side of my equation. Nothing to really do on the right side, but the left side I got some work to do. N squared minus n squared, those go away. These guys come together to give me a negative 5n, that's my n terms, plus 12 is equal to n minus 6. And here we go, a problem from like chapter 3, right? We can do this pretty easily. Move our n terms over to one side, our constants over to the other. When this n comes over here, I get a negative 6n. When this 12 goes to this side, I get a negative 18. And finally, n is equal to positive 3, because they both cancel each other out, yeah? Hopefully that makes sense. And since positive 3 is not one of the, you know, the problems that we should, or the values that we should avoid, we're comfortable saying that n is equal to 3. Let's go on to this next one. So sometimes we can have multiple solutions, and it looks like I did not carefully erase those multiple solutions when I copied and pasted. So I'm just going to erase this. I don't know if those are the answers, but we'll say. Let's go ahead and do our thing. So what we would do in this situation is the same. We're going to come up with a common denominator, and it will be a times a plus 1. Now that I have my common denominator, I need to figure out what my new numerators will be in order to honor the original fraction, but make sure that we can maintain this similarity in denominator. And here they are. Looking at these, you can see if I canceled out what I can cancel out in the numerator and denominator, I will get back the original fraction, or the original problem. And so now I'm going to decide what a cannot be. A cannot be 0, or a cannot be negative 1, okay? Since a can't be 0 or negative 1, and I've already gotten a common denominator, you know my favorite thing to do, the denominator no longer matters to me. And so now I'm going to treat this like a regular problem that I've done before. So this is what we end up with. And now to finish off by distributing and getting ourselves together, we get 4a plus 3a plus 3 is equal to a squared plus a, joining some like terms together. But when I see this a squared and nothing that's canceling it out, like in that last problem where our n squareds canceled out, I know that I have a quadratic situation. So what I'm going to do is, when I solve quadratics, I need to move everything over to one side, and I need to put it in quadratic form. You guys remember that? quadratic form, that's the form I'm thinking about? Okay. So that's going to require me to put everything on the right side so my a squared is positive. Does that make sense? I hope so. So a squared is going to stay over there, and now I'm going to bring these guys over to the other side. When they go over to the other side, they change sides, so that, or I could simplify here. Maybe that's smarter. So if let me simplify on the left first. So I have a negative a plus 3, and now bringing everything over to the right side shouldn't be too bad. This negative a becomes a positive a, so it joins a to become 2a, and this positive 3 becomes a minus 3, and now everything is equal to 0. I can factor that because that's how we solve these. And when I do that, I get a minus 1 times a plus 3, and that's going to I can FOIL that out, and I can multiply that back together and be confident that that's how it factors. And then a is equal to 1, or a is equal to negative 3. And again, since we have no contradiction with our earlier restriction, we know that this is an okay answer. Again, you can plug it back in and check if you'd like. Not a problem at all. Let's go on to another example. So I'm getting ahead of myself. Let's read the problem. I started solving the problem without reading it to you guys. Let's go. Lawn care. Abby has a lawn care service. One day she asked her friend Jamal to work with her. Normally it takes Abby 2 hours to mow and trim Mrs. Harris's lawn. When Jamal worked with her, the job took only 1 hour and 20 minutes. How long would it take Jamal to do the job by himself? Okay, so this is like the problem that I was talking about earlier, but it's written in it's written in a different way because we don't have rates for both people. If we did have rates for both people, here's how we would do it. We would generally think about it in terms of time divided by their hourly rate. So T over 2 will refer to what Abby can do in T amount of time. So if Abby had 1 hour, she can do 1/2 of the job. If she had 2 hours, she could do one whole job. Does that make sense? All right, hold on to that concept. So over here, Jamal, since they're working together, they will be working at the same time. And we would need to know Jamal's rate, which we don't know, so that would be X. So Abby's rate at this particular time and Jamal's rate, which we don't know at this particular time, same time, would have to equal one whole job done. So that's the premise that we're starting with. But here's our situation. We don't know what his rate is, but we do know their time. So their time together is that they were able to take 1 hour and 20 minutes to actually complete the job. So this T I can replace with 1 hour and 20 minutes, which if you think about it is 4/3 of an hour. So I'm going to replace T with 4/3. So now that I have this 4/3 situation and I'm able to replace T with 4/3, I only have X as a variable. So this is kind of cool. We can do this. Let's go ahead and see how we'll push through. So here's what I'd like to do. I'd like to simplify this fraction because it's bugging me. I don't know about you. This is 4/3 divided by 2, which we knew from a long time ago is really the same thing. It's us thinking again. 4/3 divided by 2 is really the same thing as 4/3 times 1/2, right? Times the reciprocal. And so 4/3 times 1/2 is going to be 4/6. And how can I rewrite this in the same way? I'll do the same process. I know that it will be 4/3 divided by X, which will really be 4/3 times 1 over X, which is 4 over 3X. And that's equal to 1. Well, now I know you guys can solve this because we've been handling some tough problems. What's our common denominator? Well, honestly, before we do that, I really am looking at this fraction and thinking I could write it as 2/3, right? 4/6 is really 2/3. So really, I can write 3x as my common denominator, and I can continue it on like we did last time. So this would be 3x over 3x. This would be 4 over 3x as it is. And this guy over here would now be 2x over 3x to end up giving me my 2/3, which came from the 4/6. Yeah? And then so now, what can x not be? We know that x can't be 0, which makes sense. Given the situation, he doesn't have a rate of 0. Now we've got 2x plus 4 is equal to 3x. We can solve this equation like we would any other. When we subtract x from both sides, we get that 4 is equal to x. And therefore, we know that it would take him, what were we looking for? His hourly rate. It would take him 4 hours to do the job. So 4 hours to do the job together, they end up doing the job in 1 hour and 20 minutes. Make sense, guys? I hope it does. So let me write it down as a sentence. Jamal would take 4 hours to do the job alone. All right, this is enough for this video. Let's go ahead and pick up the rest of this section in another video. Take